Since we already understand the structure of Hadoop, let's use Hadoop and compare it to Spark to understand how the Spark system works, in addition the advantages of Spark. The advantages of Spark compared to Hadoop include faster analysis capability due to these reasons. Spark also has Spark streaming, where real-time data streaming analysis is capable through this technology. Spark streaming uses micro-batch technology. Machine learning functionality is another major advantage of Spark. The machine learning library has programmable algorithms that can think and automatically update to changing conditions. Machine learning requires the capability to learn through statistical modeling and simulation. Based on changing conditions, an ideal solution is derived and adapted. Another reason Spark is faster is because it uses random access memory. You can see that Hadoop is slower because it uses HDD drives, where RAM-based operations are much faster. If the data batch size is larger than the Spark in-memory RAM size, then overflow cache datasets can be transferred to local memory. Option 1 would be a solid-state drive, and option 2 would be a hard disk drive. Of course, the SSD is preferred as option 1 because it's much faster, which we will soon look into the speed options. Overflow cache datasets are recomputed on demand when needed. Approximate speeds will be compared based on the unit of bits per second, which uses this notation right here. From a CPU to a hard disk drive, the access time will be about 2 to 12 milliseconds, where the transfer speed of the data itself will be about 800 megabits per second. Looking into CPU to SSD, it has a much shorter access time, and the speed of data transfer will be about 4.8 gigabits per second. This is 6 times faster. Then from CPU to RAM, the access time will be 0.001 to 0.05 milliseconds, which is much smaller, and the data transfer rate will be 80 gigabits per second. This is 16.7 times faster than SSD and 100 times faster than HDD. Also, the network speeds. We have gigabit Ethernet at 1 gigabits per second or higher. We have fast Ethernet at 100 megabits per second speeds. And we have Ethernet at 10 megabits per second speeds. The specifics for the protocol would be listed like here for gigabit Ethernet. For fast Ethernet, these are the standards. And for Ethernet, these are the standards. Looking into the speeds altogether, you can see that RAM to CPU is fastest, then SSD to CPU is next, and then HDD to CPU is the slowest among the three. In addition, what you can also see is that the networking speeds of gigabit or 100 megabits per second related based on the network. The Spark system was designed considering these speed differences, and it was overall optimized to provide maximum performance on a cluster in a distributed processing fashion. MapReduce features. MapReduce enables processing and generating large data sets with a parallel distributed algorithm on a cluster. It enables users to easily analyze data with high-level operators. It is easy to execute parallel computations on a cluster of databases. It takes care of work distribution. And it is highly reliable and fault-tolerant. What are the issues with MapReduce? Well, data sharing and multiple-stage MapReduce job processing is commonly done by reading data from HDFS, executing MapReduce, have the output wrote to the HDFS, and then repeat this procedure again and again and again. Studies show that many Hadoop applications spend more than 90% of their time doing the read and write process to and from the HDFS. And this is the time-consuming process that was reduced by taking advantage of in-memory RAM in Spark. Hadoop will be slow for iterative and interactive applications requiring distributed data parallel job processing and sharing. MapReduce is slow in data sharing due to slow replication, serialization, and disk input-output time consumption. We'll of course talk more about these factors. I already talked about replication factors in my Hadoop lecture. We'll also include further details on serialization. Iterative operation is a multi-stage process that reuses intermediate results for multiple computations in a series for the application. Compared to Spark RDD, Hadoop is slower because of the multiple read and writes to the HDD HDFS. And Spark is faster because it uses and takes advantage of in-memory RAM. Looking into a MapReduce portion of Hadoop, you will see that from the HDFS, it is read and the map process is done. Then it's saved back into HDFS, and then it's read out again to do the reduce process, and then it's saved back again. Iterative operations looked at a macroscopic point of view. You can see from HDFS to MapReduce to HDFS to MapReduce, and this process may be repeated multiple times. And then eventually back to Hadoop HDFS. Where in Spark, the process of RAM will be intercepted instead of the going back to HDFS process, and this will speed up the process tremendously, especially for the internal part, which needs to be repeated multiple times. The speed advantage of RAM will be tremendous, and the final result could be saved in Cassandra. Interactive operations are operations that run multiple queries on the same dataset, and Spark has tremendous advantages in here. Commonly requires queries that are executed in parallel on the same dataset. For Hadoop, MapReduce will conduct multiple writes and reads on the same dataset in the HDD to run these multiple queries. Each query will write and read to the HDD individually through the input and output ports to the HDD, and this can dominate the overall time it is consuming. For example, looking at Hadoop HDFS with all these 5 queries that we need to process, well, taking turns in the readout could be very, very tedious. For example, 1, 2, 3, 4, 5, to satisfy these 5 queries and to obtain these 5 results. In Spark, we have a default RDD processing capability, which uses a Spark DAG. And this is a series of transformations that are set up, and then they're executed together in an optimal way. These are recomputing each time an action is executed. Due to much faster RAM input-output speeds, Spark is much faster than Hadoop in interactive operations. One of the key factors that makes it so fast, in addition to using RAM, is the persisting RDD processing. Now, within the DAG, a specific RDD processed output can be saved on RAM, and it can be used for additional query-based processing. Since the RDD intermediate processed results is persisted, it can be immediately reused by interactive queries without additional processing. Thus, Spark is significantly faster than Hadoop. For example, from the Spark RDD, I process it and I save it on the RAM. And then I can share it with these queries that I have. In addition, I can persist it. In other words, if an intermediate result is needed, then I will go ahead and do query 1 and then persist the result 1. I will use result 1, send it back to a RAM, and then use it to satisfy these queries. So therefore, these queries do not need to repeat query 1 that was a part of them that needed to be processed. And then I can obtain these results much quicker. This is what we mean by using Spark persisting. Flexibility in switching tasks is another thing we need to look into when we compare Hadoop and Spark in their processing speeds. In Hadoop, the job tracker sets up task trackers where each task tracker assigns slots to be either a map slot or a reduced slot. Slot assignments cannot be dynamically changed during the application process. Slot function reassignment by the task trackers need permission from the job tracker, which consumes time. In Spark, exchange of an assigned transformation or task to a core is flexible and fast because it is based on threading. Compared to Hadoop, Spark is much faster and can easily change processing threads of a transformation or task assigned to a core. In addition, parallel processing speeds. Spark executes parallel processing based on multiple threads being operated on multiple cores simultaneously. Hadoop executes parallel processing based on simultaneously controlling multiple process IDs based upon the map and reduce slots that were predefined. And this is why Spark has a much higher utilization of cores compared to Hadoop. These are the references that I used, and I recommend them to you. Thank you.